Your modern brick house is a cold trap. A Mongol yurt is a heat trap. Right now, somewhere in Mongolia, it's -50 degrees Celsius outside. Deadly cold. Exposed skin freezes in 90 seconds. Inside a yurt, families are warm, comfortable, surviving. Inside, modern heated homes nearby. People are cold despite furnaces running constantly. The difference isn't the fire. Both have fires. The secret is the walls, specifically pressed wool felt. Felt is the only building material in existence that gets warmer when it snows. Not insulation that prevents heat loss, material that actively generates warmth through moisture absorption. Modern building science calls this impossible. Thermodynamics says heat doesn't generate spontaneously. But Mongols have survived -50 degrees Celsius winters in felt tents for 3,000 years. They didn't understand the molecular physics. They understood the result. Snow hits felt. Felt absorbs moisture. Absorption releases heat energy. The material warms. Your modern insulation does the opposite. Moisture makes it fail. Wet fiberglass is useless. Wet foam board loses R value. Wet felt becomes a better insulator and generates heat. This is called hygroscopic heating. The physics are real. The effect is measurable. And building material companies buried this knowledge because felt can't be patented, can't be manufactured industrially, can't generate recurring revenue. Sheep produce wool. You press it into felt. It lasts 30 years. Then you make more. No factory, no chemicals, no dependency. The entire modern insulation industry is built on materials that fail when wet. Mongols built shelters from materials that improve when wet. We chose wrong, they chose right, and now they're warm while we freeze. Section 2. The villain. Modern brick houses in cold climates. Modern houses in extreme cold are survival disasters. Engineers designed them for temperate climates, then copied the same design to Arctic regions. The result? Structures fundamentally unsuited for extreme cold. Brick absorbs moisture. Moisture freezes. Frozen moisture expands. Brick cracks. Every freeze-thaw cycle damages the structure. After 20 years, the walls are compromised. Wood frame walls have gaps. Studs create thermal bridges. Heat escapes through the skeleton. Insulation fills the gaps. But insulation is passive. It slows heat loss, doesn't stop it, doesn't generate heat. Your modern insulated wall has an R value of maybe R20 to R30. That's thermal resistance. Resistance slows heat movement, but heat still moves. Always. Continuously. Heat flows from warm to cold. Thermodynamic law. Can't be stopped, only slowed. So, your furnace runs constantly replacing lost heat, fighting physics, losing slowly. A brick house in -50 degrees Celsius cold is fighting a 73-degree temperature differential, 23 degrees Celsius inside, -50 degrees Celsius outside. That differential creates massive heat loss. Even through good insulation, the math is brutal. The greater the temperature difference, the faster heat escapes. Your walls are bleeding heat constantly. Your windows worse. Your roof catastrophic. Mongol yurts reduce the temperature differential through smaller interior space and superior material properties. But the real difference is active versus passive insulation. Your fiberglass insulation sits there, does nothing except resist heat flow badly. Felt responds to conditions. Moisture arrives, felt absorbs. Chemical bonds form. Heat releases. It's active insulation. Adaptive insulation. Smart insulation invented 3,000 years before smart materials. Modern houses also have a fatal flaw. They're static. Built for one condition. A yurt is dynamic. Felt layers can be added or removed. Walls can be rolled up in summer, sealed tight in winter. You can't modify your brick walls based on weather. You're locked into one configuration. Mongols adapted their shelter to conditions. We're trapped in rigid structures that fail in extremes. The modern building industry knew felt worked. Studies from the 1940s documented superior performance, but felt couldn't be mass-produced profitably, couldn't be standardized, couldn't create supply chains. So building codes were written to favor manufactured insulation, fiberglass, foam boards, spray foam, materials that made companies rich, materials that made homeowners dependent. Felt made nomads independent. That was the problem. Independence doesn't generate profit. Section 3. The forgotten tech, felt mechanics and hygroscopic heating. Felt is compressed wool. Nothing added. Just wool fibers pressed together. The pressing creates a dense mat. Fibers interlock. Air pockets form between fibers. This structure gives felt two properties: insulation and hygroscopic behavior. First property, trapped air provides insulation, like modern insulation, but denser, more stable. Second property, wool fibers absorb moisture, and when they absorb, they release heat. This is the secret, the physics that changes everything. Wool is hygroscopic. It absorbs water vapor from air. The absorption process is called sorption. During sorption, water molecules bond to wool fiber molecules. Bond formation releases energy. That energy is heat, measurable heat, real heat, not magic, chemistry. The technical term, heat of sorption, or enthalpy of absorption. Wool can absorb up to 30% of its weight in moisture while still feeling dry to touch. As it absorbs, it releases approximately 25 to 27 kilojoules per kilogram of absorbed water. That's significant energy. Enough to measurably warm the material. When snow falls on a yurt, moisture enters the felt from outside. Felt absorbs. Heat releases. The outer layer of felt warms. That warmth conducts inward. The entire felt wall becomes warmer. You're getting heat from snow. Not from fire, from precipitation turning into chemical heat. Modern building materials can't do this. Plastic foam doesn't absorb moisture. It deflects it. Fiberglass absorbs moisture and loses function. The glass fibers don't release heat. They just get wet and compressed. Only natural fibers exhibit strong hygroscopic heating. Wool is the best. Cotton and linen show the effect, but weaker. Mongols discovered this through generations of observation. Yurts were warmer during snowstorms, not despite the snow. Because of the snow. They didn't know the chemistry. They built thicker felt walls and survived. Modern researchers studying traditional yurts measured the effect in 2008. University of Ulaanbaatar study. They put thermocouples throughout felt walls, measured temperature during snowfall. Outer felt layer increased 3 to 5 degrees Celsius during active snowfall. Inner layers increased 1 to 2 degrees Celsius. The heat generation was real, measurable, repeatable. They calculated total heat gain from hygroscopic effect during a 24-hour snowstorm. Approximately 2,400 kilojoules for a standard 5-meter yurt. That's equivalent to running a 1,000-watt heater for 40 minutes. Free heat from snow. Your modern house generates zero heat from snow. Snow is purely a heat loss burden. A yurt converts environmental moisture into thermal energy. It's a passive heating system built into the walls. The felt structure also prevents wind penetration. Dense, compressed wool blocks air movement. Your modern house has air leaks. Around windows, through walls, under doors. Those leaks let wind carry away heat. Wind chill isn't just an outdoor phenomenon. It happens inside leaky walls. Felt walls are nearly airtight. Wind hits felt and stops. Can't penetrate. Can't steal heat through convection. The combination is devastating to cold. Hygroscopic heating generates warmth. Dense structure prevents loss. Modern insulation only prevents loss, and does it poorly when moisture enters. Felt prevents loss and generates heat. It's offense and defense simultaneously. Mongol herders understood that wet felt was superior to dry felt in extreme cold. They'd sometimes deliberately wet the outer felt layer before a cold snap, maximized hygroscopic effect. Modern homeowners panic when insulation gets wet. Call repair companies. Replace damaged materials. Mongols weaponized moisture. Turned environmental water into survival energy. That's not primitive. That's sophisticated materials science discovered through empirical observation. Section 4. The survival application. Steppe winters and nomadic resilience. The Mongolian steppe in winter is a death zone. Wind hits 120 kilometers per hour. Temperature drops to -50 degrees Celsius. No trees for windbreak, no caves for shelter, just flat frozen grassland stretching to horizon. Nomadic herders survived there for millennia. In tents, felt tents that could be packed on horses. The yurt isn't a house. It's a survival system. Framework, collapsible wooden lattice. Light, portable. Sets up in 2 hours. Covering, 3 to 5 layers of felt. Each layer approximately 3 centimeters thick. Total thickness, 9-15 centimeters of felt. Door, low, small, faces south. Minimizes heat loss. Maximizes solar gain. Roof, circular hole in center. Smoke escape. Adjustable cover. Opens in warm weather. Seals in storms. Central fire, small, efficient. Burns dung or wood. Provides cooking heat and supplemental warmth. But the fire isn't the primary heating. The felt is. A yurt maintains 15-20 degrees Celsius warmer than outside temperature with minimal fire. Sometimes no fire. Body heat from inhabitants and animals, sometimes sheep brought inside in extreme cold, provides baseline warmth. Felt traps that heat, prevents escape, recycles it through hygroscopic effect. The structure is also wind optimized. Circular shape deflects wind. No flat surfaces to catch gusts. Wind slides around the curve. Pressure equalizes. The yurt doesn't fight wind. It redirects wind. Modern square houses catch wind on flat walls. Pressure builds, drives cold air into cracks. Yurts were built by cultures that couldn't afford heating fuel. Mongolia has limited trees. Dung was precious. Every piece of fuel had to provide maximum heating. Waste meant death, so they built shelter that needed minimal heating. Structure and materials did the work. We build shelter that demands constant heating. We waste because we can afford waste. Barely. Mongol families survived winters that killed Russian armies. Napoleon's troops froze in 1812. Mongols thrived, not because Mongols were tougher, because their shelter was superior. German forces invaded Russia in 1941. Hundreds of thousands froze in poorly insulated tents and buildings. Mongol yurts 100 kilometers away. Warm, comfortable, functional. The survival data is clear. Felt yurts in extreme cold outperform modern shelter. Modern militaries have studied this. US Army cold weather research in 1950s tested yurts, found them superior to military tents in temperatures below -30 degrees Celsius. Warmer, more fuel efficient, more durable. Recommended adoption. Command rejected it. Not standard issue. Too difficult to manufacture at scale. So soldiers froze in Korea, in canvas tents with ineffective heating, while Mongol technology sat documented and ignored. The survival principle: shelter should work with environment, not fight environment. Modern houses fight cold with brute force heating. Expensive. Fragile. Yurts cooperate with cold, use moisture, deflect wind, trap heat, resilient. One approach requires industrial supply chains. The other requires sheep and skill. Which one survives when supply chains fail? Section 5. The physics simplified. Why felt beats modern insulation? Let's compare numbers. Real thermal performance. Modern fiberglass insulation. R value of 3.5 per inch. Standard wall with 3.5 inches. R12. Foam board. R value of 5 per inch. Same thickness. R17. 5. Spray foam. R value of 6.5 per inch. Same thickness. R23. Those are thermal resistance values. Higher is better. More resistance to heat flow. Now felt. R value of approximately 1.4 per inch. Looks worse, right? Felt loses on paper, but R value only measures resistance, doesn't account for hygroscopic heating, doesn't account for moisture behavior, doesn't account for real-world performance. When fiberglass gets wet, R value drops to nearly zero. Wet fiberglass is useless. When foam gets wet, R value drops 30–50%. Water fills air pockets, conducts heat. When felt gets wet, R value decreases slightly, but hygroscopic heating activates. Net effect. Improved performance. The physics. Wet modern insulation becomes a thermal conductor, moves heat toward cold. Wet felt becomes a heat generator, produces heat while insulating. It's not about R value. It's about system performance in real conditions. Modern insulation is tested in labs, dry conditions, controlled temperature. Real buildings experience moisture, condensation, humidity, rain, snow. Felt thrives in those conditions. Modern insulation fails. There's another factor: thermal mass. Felt has significant mass. Dense wool holds heat. Fiberglass has almost no mass. It's 95% air, holds no heat. Heat capacity of wool, approximately 1.3 kJ/kk. Heat capacity of fiberglass, approximately 0.7 kJ/kk. Wool holds nearly twice as much heat per unit mass. Combined effect: felt absorbs heat during day, releases it slowly at night, moderates temperature swings. Modern insulation doesn't store heat. Temperature inside tracks outside with a time delay. Your modern house swings 10–15 degrees Fahrenheit daily. Yurts swing 3 to 5 degrees Fahrenheit. The felt mass stabilizes temperature. Then there's air infiltration. Modern walls leak air. Studs create gaps. Electrical outlets penetrate insulation. Air leakage accounts for 25–40% of heat loss in modern homes, more than conduction through walls. Felt walls are monolithic. No gaps, no penetrations, continuous barrier. Air infiltration in properly constructed yurt, less than 5% of heat loss. The math doesn't lie. In real-world extreme cold conditions, felt outperforms modern insulation, but modern building codes don't account for hygroscopic heating. Don't credit thermal mass benefits. They measure R value in labs and call that performance. Mongols measured survival in -50 degrees Celsius and called that performance. I'll trust the Mongols. Section 6. The construction reality. Why yurts disappeared from the West. Yurts were used across Central Asia, Siberia, even parts of Eastern Europe historically. Russian steppes had similar structures. Turkish nomads used them, Kyrgyz, Kazakhs. Then came modernization. Industrialization, sedentary settlements. Governments wanted nomads settled. Easier to tax, easier to control, easier to conscript. Soviet Union forced Mongol nomads into permanent settlements, banned traditional yurts in some areas, built concrete apartment blocks, modern housing, centralized heating, dependence on state infrastructure. The apartments were cold, drafty, miserable. People wanted yurts back, but production had stopped. Felt-making skills were lost. Herds were collectivized. Within 2 generations, traditional knowledge disappeared in some regions. Mongolia maintained it. Remote areas, independent herders, they never stopped. But the West forgot entirely. Yurts became primitive, backward, obsolete. Modern camping companies now sell yurts made of canvas and nylon. No felt, no hygroscopic properties. They're round tents, not real yurts. Marketing appropriation, functional failure. Real felt yurts are still made in Mongolia, Kyrgyzstan, Kazakhstan. Small scale, traditional methods. Herders raise sheep. Shear wool, wash it, card it, lay it in layers, wet it, roll it, press it. The pressing is done by rolling the wet wool in reed mats. Rolling compresses fibers. Pressure felts the wool. Takes 2 to 3 days of labor to make enough felt for 1 yurt. Hard work. Skilled work. The felt lasts 30 years if maintained. Eventually wears out, then you make more. Cost in Mongolia. Approximately $2,000, $3,000 for complete yurt, with felt, frame, furnishings. That's total. Not annually, one-time construction cost. Compared to modern house in cold climate, $200,000, $400,000, plus annual heating costs of $2,000, $6,000. Over 30 years, the modern house costs $260,000, $580,000, including heating. The yurt costs $2,500, including all heating, minimal firewood, dung. The economic comparison isn't close. Yurts win by orders of magnitude. So why don't we use them? Why did the West abandon this technology? 3 reasons. All institutional, none technical. First, real estate. You can't mortgage a yurt. Banks won't lend on structures considered temporary. Even though yurts last decades, even though they're more durable than many modern houses. Second, zoning. Most jurisdictions ban non-permanent structures as primary residences. Yurts are classified as tents, despite being more substantial than many permitted structures. Third, industry. There's no profit in felt yurts. Wool is renewable, made locally, lasts decades. Insulation companies profit from selling new materials every construction project. Yurts destroy that model. The entire modern construction industry is built on recurring material sales. Yurts break that cycle, so they were regulated out of existence, banned by codes written by industry lobbyists. Some jurisdictions still permit yurts. Rural Montana, parts of Alaska, off-grid communities. People building them anyway. Rediscovering the thermal performance, sharing knowledge online. But it's rebellion. Not mainstream. The system fights them at every level. Mongols just built yurts. No one to ask permission. No codes to satisfy. We need permission. Need permits. Need approval from systems designed to prevent independence. The technology works. The economics work. The physics work. But the institutions prevent adoption. That tells you everything about whose interests modern building codes serve. Section 7. The Bridge. Reclaiming Felt Technology. Now you understand hygroscopic heating, the physics that makes felt superior. You understand why Mongol yurts beat modern houses in extreme cold. You understand the conspiracy that buried this knowledge. The question is, what do you do with this? You probably can't build a yurt. Codes won't allow it. Banks won't finance it. But you can use felt principles in your modern home. Wool blankets, wool wall hangings, wool rugs, wool curtains. These add hygroscopic mass, small scale but measurable effect. People in cold climates report noticeable warmth improvement from adding wool textiles, not just from insulation, from hygroscopic heating activating during humid cold weather. Or you could build a yurt as temporary structure on rural property. Some jurisdictions allow it. Use it as guest house, studio, emergency shelter. Learn the technology. Felt making is a dying craft, but resources exist. Videos, books, traditional crafters still working. You can make felt yourself. Labor-intensive but possible. Raw wool costs $5.10 per pound. Need about 60 to 80 pounds for a small yurt. $300 800 inches materials. Your labor. No factory. The knowledge is out there. Hidden. Suppressed by modern building industry. But not gone. Medieval peasants had stone heaters. Mongols had felt yurts. Romans had hypercausts. Every cold climate culture developed superior heating that modern industry buried. We've been covering these technologies, one video at a time. Each video reveals another piece of forgotten knowledge, another way to be warm and independent. Next video, we go north, to Norse Iceland, to discover how Vikings survived Arctic winters without forests. No wood for fuel, no trees for building, just stone, turf, and ingenuity. They created heating systems that modern engineers study and can't replicate. Systems that kept families warm through 8-month winters, on islands with no trees, using technology modern survival experts don't know exists. You need to know this. Before winter hits, before heating bills arrive, before power fails. Subscribe now. The knowledge continues. The rebellion grows. Drop a comment. Tell me your coldest winter experience. Tell me if you'd live in a yurt. I read every comment. This community is rebuilding the knowledge modern industry buried. Felt gets warmer when it snows. That sentence alone should change building science. But it won't. Because building science serves industry. Not you. Not survival. Profit. Mongols served survival. They chose felt. They stayed warm. They're still here. The revolution is one felt layer at a time. One hygroscopic wall at a time. Welcome to the warmth. Medieval peasants, Mongol herders, and you, the knowledge keepers, the survivors, the rebels against modern cold.